Hello grade 11s and welcome to this video in which we will be solving multiple choice problems on electrostatics. Now very often when we study for tests and exams, we tend to neglect multiple choice problems, but they are actually very important because they help us to identify which concepts we don't fully understand. And when we're able to identify what we don't understand, we know what to spend more time studying and which questions to ask in order to improve our marks. So what I suggest is that as you watch this video, you pause as we go from one question to the next to see if in the end you arrive at the same answer that I do. We start off with question number 1, which says, two identical metal spheres on insulated stands carry equal charges and are placed a distance d apart. Each sphere experiences an electrostatic force of magnitude F. The spheres are now placed a distance half d apart. The magnitude of the electrostatic force that each sphere now experiences is A half F, Bf, C2F, or D4F. In the beginning, we know that F, the electrostatic force, is equal to K, Q multiplied by Q since the charges are equal, divided by R squared, which is now D squared, since the original distance is given as D. After they are moved, we see that the distance changes to half D. The new electrostatic force is therefore going to be equal to K, Q multiplied by Q because we did not change the charges, but we're going to divide this by half D, which we place in the place of the distance, and we still go and square this. Now if we manipulate this, we end up with K, Q multiplied by Q divided by half to the power of 2 is equal to 1 over 4, and then we still have d squared. So this exponent affects the 2, the half, and the d. If we tip and times, so if we use our mathematical rules for fractions, we end up with 4k q multiplied by q divided by d squared. So in the end, the new force is 4 times the size of the original force. And we can therefore conclude that the correct answer to question number 1 is D, 4F. Let's move on to question number 2. Question 2 says, the electric field pattern between two charged spheres A and B is shown below. Which one of the following statements regarding the charge on sphere A and B is correct? A and B are both positively charged. B, A and B are both negatively charged. C, A is positively charged and B is negatively charged. Or D, A is negatively charged and B is positively charged. When we look at the picture, all that we see is electric field lines with arrows on them. We know that the electric field lines always point away from positive and into negative charges. When we look at B, we see that the arrows point away from it. Therefore, we can come to the conclusion that B is positively charged. When we look at A, we see all of the arrows point towards it, and therefore we can come to the conclusion that A is negatively charged. And therefore the correct answer to this problem is question or answer number D. A is negatively charged while B is positively charged. Let's move on to question number 3. This question says, a positively charged metal sphere X on an insulated stand is brought into contact with an identical neutral metal sphere Y. So A is positively charged and Y is neutral, and they're both on insulated stands. The two spheres are then separated, so they're brought into contact and then they are separated. Which one of the following describes the charge on each sphere after they have been separated? When we have spheres that are charged, that are brought into contact, we remember the formula that we obtained in grade 10, which said that the new charge on each sphere can be calculated by taking the charge of each sphere, adding them together, and dividing by 2. In the end, we know that when the spheres are separated after they've come into contact, the charge on each one of these spheres is going to be exactly the same and equal to the new charge that we calculate. The answers here are A, x is positive, y is negative. B, x is positive, y is positive. C, x is neutral, y is positive. And D, x is neutral, y is positive. We know that in the end, the charges need to be exactly the same. And the only option here where both of the charges are the same is B. Both are going to be positively charged. And that means that B is the correct answer. Let's move on to question number 4. This question says, two small identical metal spheres, each carrying equal charges, Q, are brought into contact and then separated. The charge on each sphere will now be A0, B Q over 2, C Q, or D 2Q. We know that the new charge is going to equal to the sum of the charges divided by 2. Q plus Q is 2Q, and we're going to divide this by 2. In the end, we end up with the final answer of Q, which means that the correct answer to this problem is answer C. Question number 5 reads, two charges, positive 2 nanocoulomb and negative 2 nanocoulomb, are located on a straight line. S and T are 2 points that lie on the same straight line as shown in the diagram. Which one of the following correctly represents the directions of the resultant electric fields at S and at T? And here we have a whole lot of options, A, B, C, and D. In order to answer this question, we're going to have to look at each point separately, starting off with S. Let's first look at the positive 2 nanocoulomb charge over here and see in which direction its electric field will be at point S. To do so, we're going to take a positive test charge and we're going to place it at point S. We then say, where will this positive test charge move as a result of this positive 2 nanocoulombs? Since positive repels positive, we know that the test charge is going to move towards the right. So we either answer this by using a positive test charge or point charge, or we go and we draw the electric field surrounding the positive 2 nanocoulomb charge, and we see that at S it's going to point towards the right, because electric field lines always point away from positive charges. Now let's go and see how or where this test charge is going to move at point S as a result of the negative 2 nanocoulomb charge. Positive is attracted to negative charges, and this charge over here, although you can't see it, is a negative charge. So since positive is attracted to negative, we know that the test charge is also going to move towards the right as a result of this negative 2 nanocoulomb charge. Since both of the electric fields point towards the right, we know that the direction of the resultant electric field at point S is going to be towards the right. So therefore, we know that the answer over here is either going to be A or it's going to be C. But to get the complete answer, we're going to have to analyze what is going to happen at the other point, T. So to see what happens at point T, we're going to ignore point S. Let's start off by seeing what the positive 2 nanocoulomb charge will do at point T. So in which direction its electric field will be at point T. Since positive repels positive, we know that a positive test charge will move towards the right as a result of this positive 2 nanocoulomb charge. its electric field at point T is towards the right. If we look at the negative 2 nanocoulomb charge, we know that the test charge will move towards the left as a result of it. Its electric field at point T is towards the left. Now we have a bit of a problem because one arrow is pointing to the right and the other is pointing towards the left. So what is the correct answer, left or right, at T? If you look at the distance between the charges and point T, you will notice that the positive 2 nanocoulomb charge is further away from T, from the positive 2 nanocoulomb charge. T is further away from the positive 2 nanocoulomb charge. We know that the electric field is inversely proportional to the square of the distance away from it, where we are measuring this electric field. So the further the charge is from the point where we are measuring the charge, the weaker that electric field is going to be. So we know that the electric field as a result of the positive 2 nanocoulomb charge at point T is small. But because the negative 2 nanocoulomb charge is close to T, that electric field strength is going to be big. Therefore, when we add these arrows together, we get a net or resultant electric field at point T towards the left, making A the correct answer to this problem. We often think that multiple choice problems are very, very easy, but they actually are not always easy, so don't just read and make assumptions. Check to see that you're answering them correctly. But also don't spend too much time on your multiple choice. Remember, at the end, if you run out of time, you can actually go and guess and you have a 25% chance getting it correct. But if you spend all of your time on multiple choice and don't answer all of the questions in your exam, then you're definitely going to lose marks for those other questions that you don't answer. So just don't think that multiple choice is very easy, because it's not always very easy. We go on to question 6, which says, which one of the following graphs best represents the relationship between the magnitude of the electric field E and the charge at a distance r from the charge? When we look at all of these graphs, we see that they are graphs of electric field versus the charge. So that means that we are keeping the distance constant. We know that we can calculate the electric field by saying E is equal to kq divided by r squared, the distance away from the charge whose electric field we are trying to measure. Now, based on this formula, we see that E is directly proportional to the charge. Therefore, as the charge increases, the electric field should increase as well. And the answer to this problem is therefore C, where we have a pattern, or we have a graph, a linear graph that displays direct proportion. Let's go on to question number 7, which says, two charged spheres A and B are placed on insulated stands at a distance r apart. The magnitude of the electrostatic force between them is F. Now, before we read the rest of the problem, I would like to see how we would calculate F. We would say that F is equal to K, the proportionality constant, multiplied by the magnitude only of the charge on A, which is 4Q. We leave out the negative, and this is multiplied by 2Q, the charge on B. We take all of this and divide it by the distance between them squared. If we go and we simplify this, we say that K, we end up with K, 4 times 2 is 8, Q times Q is Q squared, all of this divided by R squared. We therefore have 8K Q squared divided by R squared. Now let's read the rest of the problem. It says, the spheres are now allowed to touch, and then they are moved back to their original position. So they then are still a distance r apart. The magnitude of the electrostatic force in terms of F will now be A, 8F, B, F, C, half F, or D, 1/8 of F. When the two spheres come into contact and are separated, we know that they will have the same charge. And we can calculate that by adding together the charges and dividing by 2. So we say negative 4Q plus 2Q divided by 2. This gives us negative 2Q divided by 2, which gives us negative Q as the charge, the new charge that each sphere will have after they touch and are separated. To calculate the electrostatic force that they will then have after they touch, we will say that it is equal to K. We're going to have only the magnitude plugged in, so it's Q times Q divided by the distance between them squared. This gives us K, Q squared divided by R squared. What you should notice is that the new force over there is 1/8 of the original force. In other words, the original force F that existed between them is 8 times bigger than the new force. Therefore, the correct answer here is D, 1/8F. The electrostatic force becomes 8 times smaller. So it's 1/8 of the original force. Now we look at question number 8. Question 8 says, the magnitude of the electric field at distance R from a point charge E. A point charge is E. The magnitude of an electric field at distance 2R from the same point charge will be A, 1/4 of E, B, 1/2 E, C, 2E, or D, 4E. To calculate the original field, we say E is equal to K, Q divided by R squared. To find the new field, we know that we're going to have still K multiplied by Q, but now we're going to divide instead by 2R, and we're going to square this. When we simplify this, we get KQ divided by 2 squared is 4, R squared is R squared. Now, if we use our fraction rules, we find out that the new electric field is going to be 1/4 K Q over R squared. The new electric field is 1/4 of the original field, and therefore the correct answer to this problem is A, 1/4 of E. This brings us to the end of this video.